What's up, everybody? I hope you're doing good. It's Mr. Townsend. We're going to go over our second lesson in Algebra 1. How can I solve systems using substitution? So we're going over systems of equations. That's where you have two linear equations, and at some point they cross, and that's called the solution, that point of intersection. And so what we want to do is we want to figure out where that point of intersection is. So we're going to use the method of substitution. It's one of my favorite methods. I enjoy doing it, and I hope you enjoy it as well. We have two linear equations. This one's in slope-intercept form. So what we're going to do is we've isolated y, okay, and y equals 2x plus 1. Okay, so what I can do is I can literally just put that into parentheses, that 2x plus 1, and I'm going to substitute it into the other equation where y is, because we know y equals this. We know that y equals 2x plus 1. So instead of writing y, what we're going to do is we're going to substitute this in for y. So y is going to be gone, and then we're going to substitute 2x plus 1 into that. So this will all come into, and that will be x plus 3. So x plus 3, now we're going to write in parentheses 2x plus 1 equals 17. Equals 17. So we have the same exact equation here, x plus 3y equals 17. X plus 3, now remember the parentheses that came into fact because y equals 2x plus 1. So what is the isolated variable equal? Well, that's what you put into the other equation. So y equals 2x plus 1, that's what we put in for y. So instead of writing y, we write 2x plus 1, and then we continue with the rest of the equation. So we have x plus 3, and instead of writing y, we've got 2x plus 1, that's what we put in there, equals 17. So now what we're going to do is we've gotten completely rid of y. There's no more y in the equation. We're going to solve for x. So we'll know what that x coordinate point is of the point of intersection. Okay? All right, so now we're going to solve for x. So the first thing we do is our distributive property. Okay, so we've got x plus 2x times 3 is 6x. 3 times 1 is 3 equals 17. Let's combine like terms. We've got x and 6x. So that's going to be 7x plus 3 equals 17. So what just happened? We took x and 6x and we combined those to make 7x. Okay, 1 plus 6 is 7. We can't combine 3 because those are different terms. 3 is a constant and the x's are variables. So don't try to add those together to make 10x. Doesn't work. Okay, those are two different terms. Okay, we've got constant. So what we got to do is just make sure you keep those separated. Okay, so now what we're going to do is we're going to do a simple two-step equation. Subtract 3. We've got 7x equals 14. What happened? We had to get rid of the 3. So we had a positive 3. We subtracted it to make it 0. That's why I crossed it out. Okay, and then whatever you do to one side of the equation, you have to do the other. 17 minus 3 equals 14. Okay, now we want to make that 1x instead of a 7x. So what we're going to do is we're going to divide by 7. Whatever you do to one side, you have to do to the other. 7 divided by 7, that equals 1. 14 divided by 7, that equals 2. So x equals 2. So our point of intersection, our solution, the x coordinate point, is going to be 2. So now, what we're going to do is we'll go back into our original equation over here. Okay, we've got y equals 2x plus 1. So I'm going to write that up. Y equals 2x plus 1. Okay, and then we're going to take the value of x, 2, and we're going to plug it into that. Now we could do it to either one, but this just is the simple one because y is already isolated. Okay, so what we're going to do is we're going to take that 2, and we're going to plug it in right there. All right, so we're going to have y equals 2 times 2 plus 1. That's 4 plus 1. Y equals 5. And there is your coordinate point. Okay, so we've got our coordinate point, our solution of 2, 5. Now, how can we make sure that that's correct? We can plug 2, 5 into both of these equations, and we can see if that is indeed the solution. So we'll go over here. Okay, we'll go y, well, instead of y, okay, we'll go 5 equals 2 times 2 plus 1. 5 equals 4 plus 1, 5 equals 5. That's right, so we took the first equation, we plugged our x, y coordinate point into that equation, and we made sure that it was correct. That certified that it's correct. Now we're going to do the same thing here. We got 2 plus 3 times 5 equals 17. Okay, so we got 2 plus 3 times 5 is 15 equals 17. 17 equals 17. That's right. So that point is on both the lines, so that makes sense that that is where those two lines intersect. So the point of intersection is called your solution. So we just found the solution to this system of equations. Make sure you go ahead and pause the video, take notes, ask any questions on the left. We've got x equals 3y minus 10, x equals 3y minus 10, write that down, 4x plus y equals negative 1. So we've already got one of the equations has a variable isolated. The variable is x on this first one. So that what we can do is we will put what x equals in parentheses, okay? And then we're going to draw an arrow to x. Because what we're going to do is we're going to substitute x in that second equation for what x equals, which is 3y minus 10, okay? So we'll go right over here, and we'll go 4 times 3y minus 10 plus y equals negative 1. So we wrote the same exact equation. The only difference is instead of writing x, we write 3y minus 10 because that's what x equals. Now we just solve for y, okay? So we do our distributive property. Okay, that's 12y minus 40 plus y equals negative 1. 4 times 3 is 12y. 4 times 3y is 12y. 4 times negative 10 is negative 40. Bring down the y, bring down the negative 1. Now we're going to combine like terms. We've got y and 12y. 12y and y. So that's going to be 13y minus 40 equals negative 1. Okay, so now the next step is we're just going to do the two-step equation to solve for y. So first thing is, let's get rid of this 40. It's 40 in the whole, so we'll add 40. Whatever you do to one side, you have to do to the other. That goes away. So you got 13y that comes down equals 39. Okay? If you owe somebody $1, you have 40 bucks in your pocket, you end up having $39 in total. It's your net. Or you just do 40 minus 1 equals 39. Okay, the last thing we got to do is divide by 13. Simplify it. 13 divided by 13 is 1. 39 divided by 13 is 3. So our y coordinate point is 3 in the solution. That's our point of intersection. So then what we're going to do is we're going to take that 3, and we're going to go ahead and plug it into either one of these. I'm going to plug it into the top one because that seems to be a little bit better. So I've got x equals 3y minus 10. So I'm going to take this 3, y equals 3, I'm going to plug it in to that equation. Okay, so I've got x equals 3 times 3 minus 10. Okay, that means 9 minus 10, so that's negative 1. So x equals negative 1. Okay, so our coordinate point is negative 1, 3. So just know that. Negative 3 is our point of intersection or our solution. So what we're going to do is we're going to plug it back into the equations and just make sure and verify that that's correct. So we'll take the first one. We've got x equal, or excuse me. So we'll take the first one. We've got negative 1 equals 3 times 3 minus 10. Negative 1 equals 9 minus 10. Negative 1 equals negative 1. That's correct. Okay, so that one's verified. Let's do the second one. 4 times negative 1, so x equals negative 1, so we plug it in. Plus 3 equals negative 1. So 4 times negative 1 is negative 4. Plus 3 equals negative 1. Okay, negative 1 equals negative 1. There you go. So they're both verified, both of these, with that solution. There you go. So negative 1, 3 is the solution to this. make sure you pause the video. All right, right. So this is the last one I'm gonna do. This one is a little bit more difficult, but not crazy. So here's the reason. You got the variables are both on the same side of the equation, and what we gotta do is we gotta make sure that one of the variables is isolated. That's the first step you gotta do, is make sure one of the variables is isolated. So we've got y plus 2x equals 3 and y minus x equals -9. So we can either subtract 2x out of here, or we could add x here, or yeah, that's the easiest way. So what I'm gonna do is I'm just gonna take this bottom one, I'm gonna add x to both sides of the equation. So I get y equals x minus 9. Okay, so y equals x minus 9, there's that. So I can actually just get rid of this. Okay, and there's my two equations. So first thing I'm going to do, since I have the one equation isolated, is I'm going to put parentheses for what that variable is worth. And then I'm going to draw an arrow right to where I'm going to put that in. Okay, so I've got x minus 9, okay, x minus 9 plus 2x equals 3. So what I've done is, instead of writing y, I write what y equals, and I've got it right here, x minus 9 plus 2x equals 3. I'm going to combine like terms. So I've got x and 2x, that's 3x, minus 9 equals 3. So what did I just do? I just combined x and 2x equals 3x, and then -9 came here. Okay, now I'm going to do my two-step equation here. So let's add 9 to both sides of the equation. That goes away, so I got 3x equals 12. Okay, 3x equals 12. Now I'm just going to divide by 3. Right there. So my x coordinate is 4. So combine like terms, subtract or add 9, divide by 3. 3 divided by 3 is 1, 12 divided by 3 is 4. There you go. Now I'm going to take that 4 and plug it back into either one of the equations. It doesn't really matter, but I think I'm going to do y equals x plus 9. So I'll go y equals x minus 9, and then I'm going to plug in 4 right there. So I've got y equals 4 minus 9. So 4 minus 9 is -5. So y equals -5. Okay? So my solution is 4, -5. Remember, it's always an x, y coordinate point. Don't mix those up. So my solution right here is 4, -5. How do I make sure that's right? I plug those back into the other two equations and just verify that they're correct. So that's what I'm going to do right now. I've got y plus 2. So y, I've got -5 plus 2 times 4 equals 3. Okay, so I got -5 plus 8 equals 3. -5 plus 8 is 3, so 3 equals 3. Okay, that's correct. Now let's do it to this one. I've got -5 equals 4 minus 9, -5 equals -5. That's correct as well. So there you go. You know that the solution is right. So remember, first step, we want to make sure that we isolate one of the variables to one side of the equation, put parentheses around the other side of the equation, plug it in to the other equation, then we're going to solve for the variable that we isolated. So in this case, we got rid of y because we substituted it out. With x, we solve for x, we plug that in, solve for y, verify it, bada bing, bada boom. So the worksheet is going to be on the Google Classroom. Make sure that you guys download that. If you can't print it out, what you can do is take a piece of paper and look at it and write it down, and then that piece of paper will verify that you did that. So make sure you get that done and email it back to me. You could probably Google how to take a screenshot, Google how to take, I mean, you guys all have phones, take a picture. I've already gotten a lot of pictures. Just email me the picture of your homework, label it right. That's it. Hope you guys have a great day. Hope you guys are staying safe, staying healthy. Just remember, go Boomers.